Hello students, in this video we have 5.19 additional exercise problem of chapter 5. Question is, a telephonic cable at a place has four long straight horizontal wires carrying current of 1 ampere in the same direction, east to west. The Earth's magnetic field at the place is 0.39 Gauss and the deep angle is 35 degrees. The magnetic declination is nearly zero. What are the resultant magnetic field at points 4 centimeter below the cable? I think the question is zero point 0.4 centimeter above as well as below. So we will find out both. Now let us first understand situation. We know that in case of Earth, geographic north-south and magnetic north-south both are different. So if this is say north, which is geographic north, and south, geographic south, then the magnetic north-south are not along this line if the declination is not zero. But in this case, we are told that declination is nearly zero. It means that the magnetic north-south, Earth's magnet is also along this geographic north-south line, and then this becomes magnetic south, and here is magnetic north. Okay, and so if this is geographic east, geographic west, then magnetic east west is also on the same line, and then we can say that wire or cable is perpendicular to the Earth's magnetic field. Now, uh, how do we find out resultant magnetic field? Because wire will have its own magnetic field, and Earth is also having its own magnetic field. So how do we find out the resultant magnetic field at 4 centimeter distance? So for that, let us try to understand the situation from slightly different perspective. Consider uh, a magnet, say a wire is placed in such a way that it is passing through the poles of magnet as shown here. Say this is south pole, this is north pole, and the wire is passing through the gap between like this. So now, if you apply right hand thumb rule, you realize that the magnetic field lines are around the wire, around the wire in such a way that above the wire curling is like this, below the wire is like this. It means that below the wire, below the wire, the external field is going from north to south, whereas field of the wire is going in opposite direction. This is the case below the wire. Okay, to understand this, you will have to keep your thumb along the current, and then curl your fingers around the wire, and you realize that your fingers are going like this. Okay, assume it is hand, and that is how you will get it. Above the wire, the field is external field is from north to south, and the curling of finger is also in the same direction. So above the wire, both fields are added. So if you want to find out the field, resultant field, what you have to do is, when you are talking about the point above the wire, above the wire, resultant field is field of earth plus field of wire. But now I have to consider direction also, because there is deep angle, and then this will be a vector sum. Okay, so BE comprises of BH plus PB, Okay, let it be. I'm not mentioning direction, but keep there is some component. Keep it in mind. There are some components. So now, horizontal component of Earth's magnetic field and wire both will be along the same line, and hence, what I have to do is first I have to find out BH plus BW. Let it be in I cap direction, then BV will be in J cap direction. Okay, and then I can say that B square is BH plus BW whole square plus BV square. This is when you are above the wire. What if you are talking about some point below the wire? So when you are below the wire at that time, look at the figure. Below the wire, the field of wire and the external field, that is Earth's field, both are opposite. And considering deep angle, I have to subtract this only from horizontal component, and then my equation will be B is equal to BH minus BW I cap plus BV J cap. Now be careful, I cap J cap is just to show that the two components are in different direction. Okay, it can be any other direction. Here I am considering horizontal component to be along x direction, vertical component to be along y direction. And then the resultant field, if it is B prime, let it be B prime, is BH minus BW whole square plus BV square. So let this be equation 1 or result 1, let this be result 2. Now the question is, how do we find out BH, BV, BW? So we know that tan theta, deep angle tan theta is opposite by adjacent. Okay, so here we are told that B is 0.39 cos. Resultant field, Earth's field is this much, and we have one more formula. Cos theta is BH by B, and you can also take sin theta to be BV by B. So how much is theta? Theta is 35 degree. Theta is 35 degree. So make use of these three equations. You have B available, you have angle available 35 degrees, so you should be able to find out BH and BV. Okay, so find out BH BV from this formula. Next, how do I find out field of wire? BW also I'll need. So we know that for straight wire the formula is mu 0 I by 2 pi r. How much is r? We want magnetic field at 4 centimeter distance, so r is 4 centimeters. How much is I? I is 1 ampere, but now I have 4 wires, and then I'll have to consider 4 here. Okay, why 4? Because we have 4 wires. So whatever you get, whatever answer you get for mu 0 I by 2 pi r, multiply it with 4, and that is how you'll have BW. So first part is to calculate BVBH, second part is to calculate BW, third part is to find out uh, B square and then B prime square. Okay, so that is all about this problem. Carry out calculation and get your answer. Thank you.